Yeah. Okay. So yeah, we have in the problem here, we have a total of 100 politicians. Yeah. And these politicians, each of these politicians, it is said, they'll either be crooked or honest. So it's sort of an XOR scenario here, right? They can either be crooked or honest, neither both nor none, right? Each of these politicians, crooked or honest. That's what we know. And other than that, the other two things that is already also stated is that of these 100 politicians, at least one is honest. There can be more than one, obviously. There can be more than one who's honest, but at least one of the 100 politicians is honest. Also, we know that if you were to pick any two politicians out of these 100 politicians, always at least one will be crooked. For every choice, please pay attention to this part. For every choice of two politicians, that is, if you keep picking any two politicians randomly, if you keep doing that for every single choice of two out of these 100 politicians, at least one of the two will be crooked. Both can be crooked, yes, more than one can be crooked, but at least one will be crooked from all your choices, from all your possible combinations of two politicians from these 100. That is what you should understand by reading this statement. For every choice of two politicians, at least one of the two was crooked. What does it mean? It means that if we pick any two politicians from this 100, and if we keep doing that, all combinations, for all possible combinations, at least one will always be crooked. Okay? All right, these are the things that we know. Now we have to determine how many politicians of these 100 are honest and how many are crooked. That is what we have to determine. How to do that? What we will do, the path to solution to the solution that we will approach is combining these two statements. All right. So first, we know that at least one politician is honest. At least one. There can be more than one, but at least one politician is honest. We know that. Now, for every choice of two politicians, at least one of the two is going to be crooked. So when we do this, when we pick these two politicians of the 100, when we pick these two politicians, what if we pick that one honest politician that we know for sure is there? Because it says that at least one of the politician was honest. So there we know that at least one honest politician is there. So what if we pick that one politician, put it in our choice, all right? Put it in the pair, put that politician in the pair and keep that politician fixed. That is, that one honest politician will always be fixed in the choice of the two politicians. In the combinations, in all combinations, that politician will be fixed. So in this choice, one position is filled up by that one honest politician. For the other position, what do you guys think? The other person in this choice, can that person be honest?
No,
No, miss, it
No.
has to be
Why?
crooked.
Why?
because for every
Because
choice
at
of
least
two
one of the
politicians,
two
at
At
least
was
least one.
one of the two was
Exactly.
true.
Very good. Exactly. So the other one must be crooked, right? So the other one will always be crooked, right? If the first politician is fixed at the honest one, how many politicians do you have left? You have fixed one. How many other choices do you have for the politicians?
one.
99.
99. You have fixed one of the politician to the honest one. In the choice, one of the politician is the honest politician that we have. Other than that, we have 99 politicians. Okay, and now we will go over each of these 99 politicians. We'll go over each of these 99 politicians and put each of the politician in the choice and see what happens. Okay, now also you've said that the other politician will always be crooked. So you see, of the 99 other politicians, whichever politician you would pick will always be crooked. And when can that happen? Only when all the 99 politicians are crooked. As simple as that. That is the solution that we have laid out. So let's say A is an honest politician and B can be any other politician. All right. So in that choice of two politicians, if we fix A. If A is fixed, then the other one will obviously be crooked, right? Because at least one of A and B has to be crooked in the pair. At least one of A and B has to be crooked in the pair. And we know that A is an honest politician. So it follows that B is always going to be crooked. And B is always going to be crooked will only be true if all the other 99 politicians are crooked. All right. So there you go. One honest politicians and 99 other are going to be crooked.
Miss,
Yes.
can we not say that if we take, like from the start, if we take one slot to be the crooked politician and like the rest 99 random, like can it not be the rest 99 are the honest one and the one crooked is fixed?
No, we can't say that really, because you see, at least one of the two was crooked, right? But it doesn't say that both cannot be crooked, right? If you fix one to be crooked, the other one can also be crooked. See, in the pair, at least one has to be crooked, right? If one is crooked, you cannot really necessarily say that if one is crooked, the other one must be honest. You cannot say that. If you fix one to be the honest, you can say that the other one must be crooked. In this choice, in this pair, if one of the politician is honest, what does that mean? The other one must be crooked, because it says that at least one has to be crooked, because of the fact that at least one has to be crooked. But if you fix one of the politician, if you go at it the other way around, what you're saying, the other way around, if you fix one of the politician in the pair to be crooked, it is not necessarily going to be the case the other one must be honest. Because in this pair, it says that at least one will be crooked. It can also be the case that both are crooked, right? So the other one might not be honest. So you can't actually go by that logic. And if you're getting confused by the first statement, it says that at least one of the 100 politicians is honest, not in the pair. At least one of the 100 politicians is honest.
Means then why are we thinking that one is only honest? There can be more than one.
Yeah, there can be more than one, but it's possible that there can be more than one unless you combine these two statements. If you combine these two statements, it's not possible that there's more than one honest politician. And why is that? We've already stated the reason here. See, here, the first statement alone, the first statement tells us that there can be more than one honest politician. Yes, you're right. However, combining the second statement, if we take that at least one politician was honest, right? So we know that at least one is there. So if we take that one honest politician, put it in our choice, fix that politician in that choice, that A choice, in this choice, one will be fixed. And the second one can be anything. Now, the second one, as we see here, based on the condition here, always has to be crooked. So because of this fact, we're saying that all the other 99 politicians must be crooked. Otherwise, if the other 99 politicians, if you say that there are more than one honest politicians, if you claim that there are more than one honest politician, in that case, you would get to a certain pair where the other politician is honest, right? Since you have this scenario here where they're saying that at least one will always be crooked, that's why we can say that. There was another observation from one of the students from the last session, that another way to go at this, another way to look at this is that at least one in the pair will be crooked, right? Another way to look at this is that both politicians in the pair can never be honest. Makes sense, right? If it says that at least one has to be crooked, what does it also mean? It also means that both politicians in the pair cannot be honest at the same time, right? Guys, what do you think?
Yes, ma'am.
Makes sense?
Yes, ma'am.
But
Makes
how
sense?
does
Yeah.
it prove that the rest 99 will be crooked?
Yeah,
It
I'm
could
getting
be.
there. I'm getting there. Okay. So, but do you understand that at least one will be crooked in the pair also means that both can never be honest at the same time? Does that make sense?
Yes, miss.
Okay.
Yes,
If that makes sense, now think about it. If both cannot be honest at the same time, if we have this restriction, what does it mean? If both cannot be honest, It must mean that there must not be more than one politician. See here, what does it say? Every choice, for every choice of two politicians, every choice of two politicians. If we are allowed to make every single choice, if we are allowed to make any possible combination.
Yes, but this does not state that one has to be honest in this choice.
Yeah, it doesn't. No, I'm not. I'm talking about the second approach, the other approach. So even if you don't think about that, just consider the fact that what the second statement says. All right, the second statement says that both politicians cannot be honest at the same time. We established that, right? Think about it. Both politicians cannot be honest at the same time. Why cannot they be honest at the same time? Why? Therefore, in the second statement, they said we are allowed to make any possible choice for every choice of two politicians, right? For every choice of two politicians. That is, this pair. For this pair, you can come up with any combinations from these 100 politicians. You can pick any two politicians in random. Couldn't you say, এটা কি বলতে পারতে না, that if there were more than one honest politicians, একটা honest politicianer বেশি যদি থাকতো, in that case, at one point or the other, you could have come up with a pair where both are honest, or more than one is honest. You could have come up with a pair, but you cannot do that. The statement here says that that will never be the case. Why will that never be the case? Think about that. আরে যদি এখানে আমার 100 পলিটিশিয়ানের মধ্যে একজনের বেশি যদি অনেস্ট থাকে, যদি একজনের বেশি অনেস্ট পলিটিশিয়ান থাকে, তাহলে তো it's possible, it's very much possible that at some point I'll pick any two politicians at random and both of them are going to be honest. It's possible. But the second condition here says that it will never be the case. So why will it never be the case? The only reason that this can never be the case, the only reason could be that there cannot be more than one politician. Okay? And in the first approach, the one that I originally talked about, the one that we talked about here, see, we're not saying that in this choice, the choice of the two politicians, the pair that you pick, in that choice, we're not saying that one always has to be honest. We're not saying that. It doesn't say anywhere in the question, so we are not claiming that either. In the question, it only says that at least one will always be crooked. However, to prove our point, just to prove our point, we are saying that in this choice, what if we are allowed to make any choice, right? We are allowed to build any sort of combination. What if we always fix one of the positions of the pair, one of the politicians in the pair? What if we fix it to the honest one? We have at least one honest politician, right? What if we fixed one of the politician to the honest one? একজনকে যদি honest politician টাতে fixed রাখি, if we always keep A fixed in this pair, if A is always fixed, then what must it mean? It means that B is always going to be crooked, because at least one has to be crooked. And if B is always going to be crooked, what does that mean? B সবসময় crooked হবে, A honest. All right? And A is fixed in the pair. And B can be any other politician. See, A is the honest politician. A is that one honest politician. And B can be any other politician. She crooked hook or honest hook, whichever, any other politician. Now, in this pair of A and B, A is fixed, B can be any other politician. However, the second statement says that at least one will be crooked. Now, since A is an honest politician and at least one of the two has to be crooked, then B must be crooked. B will always be crooked. Whichever politician you pick, B will always be crooked. যে কোনো politician pick করলে B will always be crooked. And when will that be true? এই জিনিসটা কখন হবে? Only if the other 99 are crooked, all right? Okay, before that, let's go step by step. Does it make sense to you that in this pair, if we fix one politician to A, then the other choice for the other politician, B, will always be crooked. Does this make sense to everyone? Does anybody has any question regarding this part?
No, miss.
Everybody clear on this one?
Yes, miss.
Okay.
Yes, ma'am.
All right. If that makes sense to you, okay. Now think about it. If B is always going to be crooked, you have 100 politicians. ঠিক আছে? Among these 100 politicians, you can pick any 2 politicians and make a pair. And in that pair, we are saying that always we will fix one politician to A. That is, একটা politician always A হবে. ওটার ক্ষেত্রে, we are not going to shuffle. We are not going to go over this entire list and keep picking politicians. One position will be fixed to A. And we know that A is an honest politician. At least one honest politician আছে না? Let's say that A is that one honest politician. There can be more. We don't know that yet. There can be more, but A is that honest politician. So একটা position fixed. The other one, for the other position, for the other politician, we can go by this list one by one. একজন করে pick করতে পারি. We still have 99 politicians left, right? They can be either honest or crooked. We don't know yet. Fine? Okay. So for the second person in the pair, for the second politician in the pair, we can go through this list one by one, pick one by one, all right? And make the pair. However, remember that whichever politician you pick, B will always be crooked because of the second statement, right? A pair A, B will always be crooked. So you see, baki 99 politicianer মধ্যে, if you go one by one and you pick one by one, whichever one you pick, go one by one, যেটা ইচ্ছা করো, that they will always be crooked because the first position is taken by an honest politician. The second one will always be crooked. And we can do this because for every choice, we can make any possible combinations, right? So to prove our point, let's fix one of the positions to A, who is an honest politician. And what does that mean? But that means that for the second politician, if we go through the list of the rest of the 99 politicians, they'll all turn up to be crooked because at least one has to be crooked. One is already honest, the other one must be crooked. So among the rest of the 99 politicians, whoever you pick will always be crooked. And that means that the rest of the 99 politicians are crooked. Okay. Now, any questions? I believe there were some. Do you guys still have some questions left?
No, miss.
Okay.
Miss,
Yeah, Fahim.
এখানে যদি আমরা like fix না করি, if you don't fix that A has to be an honest politician, we can't really solve this puzzle, right? We
Yeah.
have no options. Rather than selecting, I mean fixing A, we don't have any other solutions.
There can be other approaches, but this is the simplest or most straightforward way to solve this. That if you fix A, you don't have to. See, you don't have to. It doesn't say anywhere that a pair মধ্যে A will be fixed or one will be honest. But we're following this approach to prove our point. You see that if we fix one of the politician at A, you see the other one has to be crooked. And why must that be? Only because the other 99 are crooked. Just to prove that point, we fixed it at A. Make sense?
Yes, miss.
Okay.
Miss,
Yes. So yeah.
Miss, like, what if there's more than one honest? Then what should we do?
Will there be more than one honest politician? That is the point. That is the point. I mean, what if is not the situation? You have to get to the conclusion. 99 other are crooked means what? You got to the conclusion that 99 politicians are crooked and only one is honest. We got to this conclusion. What if it's not possible? What you're saying that more than one honest politicians will be there does not make sense. If you look at only the first statement, at least one politician was honest. Yes, you can say just by looking at the first statement, শুধুমাত্র এটার উপর যদি focus করি, we can say that yeah, একজনের বেশি honest politician তো থাকতেই পারে. However, when we look at the second statement tells us what? That at least one of the two will be crooked. Right, Sualia?
Yeah, I got it now.
If at least one will be crooked, যদি at least একজন crooked থাকে এই পেয়ারের মধ্যে, that means what? You can never land yourself a pair where both are honest, right? You will never get yourself a pair where both are honest. এটা চিন্তা করো যে এটা কেন? Why is this the scenario? এটা কেন হচ্ছে? Why can I not ever find a pair where both are honest? Why? It must be because there simply isn't more than one honest politician. What? Sorry?
No, miss, I said there's a condition, like one has to be crooked.
Exactly. One has to be crooked. Yeah. Because of that, we got to the statement that, yeah, at least one of the two is crooked. That's why we are saying that both cannot be honest at the same time, right? But then again, think about what that must mean for the 100 politicians. Both can never be honest. You are allowed to make every possible choice, right? And they're saying that you will never land with a pair where both are honest. Think about that, Jay. If I'm allowed to make every possible combination, then why is it the case that never both politicians in the pair will be honest? Never. Why? It must be that simply একজনের বেশি honest politician এখানে নাই. That's why, because একজনের বেশি যদি honest politician থাকতো and you're making every possible choice, is it not possible that at one point or the other you're making every possible choice? If there were more than one honest possible, is it not possible that at one point or the other you had a pair where both are honest? যদি একজনের বেশি থাকে এটা তো পসিবল, চোখ বন্ধ করে দুটো পলিটিশিয়ান পিক করছো, both can be honest, it's possible. However, the second statement says that it will never be the case. এটা কখনো হবে না. Why will it never happen? It must mean that simply there aren't more than one politician at all. Okay, that is another approach to it. This is
Ma'am, if we don't keep A fixed, then at every single other pair, there might be one honest and one crooked.
if you don't keep A fixed there, then you don't know what's going to happen. I mean, like, if A is not fixed, both can be crooked or one can be crooked. It can be any scenario, yes. But
Yes, ma'am.
here our goal is to prove our answer to the puzzle. Okay, if your answer to the puzzle is that there can be more than one honest politician, then I think you still haven't understood what it means to combine this, what it means once we combine these two statements. Okay, so first think about it, Brishti, that okay, forget about this solution, forget about this. Okay, do you understand that, AJ, the second part, what it says that for every choice of two politicians, that is for any given pair of politicians, at least one will be crooked. Do you understand this?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So this also means that for any given pair, in the pair, both politicians will never be honest. That is both at the same time. Both, donota politician honest, emon kokhono hobe na. It also means that, right?
Yes, ma'am.
Yeah, because at least one has to be crooked means what? Both cannot be honest at the same time. Now, jodi tomar kache ei je 100 politician je ache, in these 100 politicians, if you did have more than one honest politician, jodi ekjoner beshi honest politician thakto, see, for every choice, right, that is for all possible combinations, ei 100 joner moddhe prottekta choice er jonno eta bola hocche, prottekta possible choice er jonno eta bola hocche, jodi ekjoner beshi honest থাকতো, এটা কি সম্ভব না যে তুমি চোখ বন্ধ করে পিক করলা আর even without closing your eyes, if you iterate over every possible choice, go one by one, প্রত্যেকটা চয়েস যদি, প্রত্যেকটা কম্বিনেশন যদি বানাও, যদি একজনের বেশি honest politician থাকে, is it not possible, would it not be possible to get a pair where both are honest?
Yes, ma'am.
Yes, it would be possible. However, the statement says that will never be the case. এখানে স্টেটমেন্টে বলছে যে এটা কখনো হবে না। সো এটা চিন্তা করো যে এটা কেন কখনো হবে না। If there are more than one honest politician, আমি তো এমন একটা পেয়ার পেতেই পারি যেখানে both of them are honest. However, the statement says that will never happen. It's a fact that we must go by. A fact that says that it will never happen. Why must it not ever happen? এটা কি কারণে এটা কখনো হবে না? Based on what grounds এটা কখনো হবে না? Only if একজনের বেশি honest politician এখানে নাই। যদি শুধুমাত্র এই কেসটা হয় যে একজনের বেশি honest politician নাই, শুধুমাত্র তখনই you will have this scenario here where both politicians at the same time will never be honest, right? যদি একজনের বেশি honest politician থাকতো, একটা না একটা পয়েন্টে তো আমি এমন একটা পেয়ার পেতাম যেখানে both politicians are honest. However, that is not the case here. The fact here says that will never happen. Now think about why will that never happen? এটা কেন কখনো হবে না? It must be because একজনের বেশি honest politician এই 100 জনের মধ্যে নাই। We don't. That is not. We don't have more than one honest politician in these 100 politicians. That is the reason. That is the reason we have this fact, the second statement. That is the reason we will never get a pair where there are two honest politicians. Simply because there aren't any more politicians other than that one honest politician. You have only one honest politician because of that. Does that make sense,
Yes, ma'am.
Bishti?
I got it now. Yes, ma'am.
Ma'am, what if
Yeah.
what if there was one crooked and 99 honest politicians?
Again, what if? What if you have to think about whether what if is possible or not?
I
You have
mean,
to combine these two statements. Is it possible?
yeah.
Is it possible? One crooked politician and all the other honest. Is it possible? It says that for every choice of two politicians, at least one will be crooked. Think about these statements.
Oh,
This statement.
gotcha.
When will this be true? It's a second statement. If you think about this statement, when will this be
Hmm.
true? For every possible choice. Every choice maneki.
This will be
I
true
can
when one
iterate
is
through the-
honest. Right.
This will be true when at least one is crooked. Okay, it doesn't say about, the second statement doesn't say about any condition on at least one honest or anything like that. The second statement says that if you were to pick any random two politicians, you would always have at least one crooked politician there. All right, that is what it says. Now think about what it means. For every choice, right? For every choice, it means that a action journal list, you can go one by one and you can make your own combinations. Okay, প্রথম দুইজনকে দিয়ে ট্রাই করলাম। Okay, তারপরে প্রথম জনকে ফিক্স রেখে থার্ড জনকে দিয়ে ট্রাই করলাম, ফোর্থ জনকে দিয়ে ট্রাই করলাম। এভাবে করে you keep iterating. You make a pair with the first two, then the second one and the third one and the fourth one. এভাবে করে লিস্টে যতগুলো পলিটিশিয়ান আছে সবগুলো পলিটিশিয়ানকে একবার করে পেয়ার করে দেখা কি পসিবল? Yes or no? It's possible, right? Think about it. Theoretically, it's possible. 100 politician. If you have, let's say, 100. If you say you had 100 cricket balls, all right, cricket balls. If you had 100 cricket balls, in that case, if you were to pick a pair, couldn't you go one by one? একটা করে কি pair বানানো possible হতো না? Similarly, it's the same idea. If you have 100 people there, you can go one by one, iterate through the list, and make all the possible combinations or all the possible choices. Remember the truth table? The idea of truth table কি করি? Truth table, for any given two variables, we come up with all possible combinations. For any given three variables, we come up with all possible combinations, right? Similar to that idea. In this list of 100 politicians, you can iterate through the list and make all possible choices, right? Every choice can be made. Yeah, every possible combination can be made. Now, think about that. The statement, the second statement, the second fact, what does it say? It says that in all these combinations, all of these, at least one will always be crooked. At least one. Both can be crooked, yeah, but at least one will always be crooked. Okay? Or in other words, in all of these pairs, both can never be honest at the same time. Now, think about it. What you were saying. শুধুমাত্র একজন crooked and বাকি 99 honest. এরকম যদি হতো, you would never get this situation. Right? Because for all possible combinations, you see at least one is crooked. For all possible combinations. শুধুমাত্র একজন যদি crooked হতো, all possible combination how would you get that crooked person, right? In all possible combination, how would you get that one crooked person? What about the rest of the 99 honest politicians? ওদের pair যেগুলো, ওখানের মধ্যে তো কোনো crooked, you wouldn't have any crooked politician at all. You see where the fault is. With what you said. If you had only one crooked and the other 99 were honest, then you would get a pair where both are honest. Or you would get a pair where none of the politicians are crooked. However, the fact here states that at least one has to be crooked. So that is not a possible solution.
Yes, understood.
Usually countries do that. Take one politician to be crooked and then compare it with the rest of them.
Well, that will not lead us to a concrete solution, will it? Because if you fix one politician to be crooked, the other one can be crooked as well, because the fact says that, the statement says that at least one in the pair is crooked. At least one. It means that both can be crooked as well, right? So if you fix one to be crooked, the other one can be crooked or honest, anything, right? The other one can be crooked, or that one honest politician that we have already shown that's there. Okay, so by this approach, what we are saying, see, A is an honest politician. Okay, A here in the first statement, we know that there's at least one honest politician. Let's say that A is one honest politician. We have this one honest politician. Whether there are more than this one honest politician or not, that is the question that we have to answer, right? So at least uje first statement e ki boleche je 100 politician er moddhe at least one is honest. Let's say A is that one honest politician, right? So we have that fixed at A. Now the question to answer is, ei je A chhara baki kono politician ki honest ache, and if so, then how many? We have to find out how many honest and how many crooked, right? We have to find out A chhara ar kono honest politician ache kina. So in this pair that we can make in the second statement, this pair, in this choice, what we are doing is we're fixing the position of A. Why are we doing that? What if jegulo tumra bolcho? See, those situations will never be possible. Ota hobei na, because that is not the conclusion to this puzzle. And why can we say that? Ei jinishta keno bolte parchi? By this approach. Now, based on the second statement, in these choices, in all of these choices, if we fix A's position, if we fix A at honest, we've already established that if A is going to be fixed in that pair, oi pair A ke jodi fixed rakhi, one politician will always be A, then the other one can be anything. And based on the second statement, we established that the other one will always be crooked, right? And hence, since the other one will always be crooked, we can say that all the other 99 are crooked. Now, most of you are asking question regarding what if we didn't fix A? What if we said that in this pair, A will not be fixed? See, this is the approach, okay? I mean, if you didn't fix A's position, then you wouldn't be able to prove anything. This is the approach to the proof. Yeah, I mean, it's not mandatory that you fix the position of A in the pair, yes. But the reason we are fixing the position of A is to prove our point that all the other 99 are crooked. You see? Because of the second statement, we can say that all the other 99 are crooked. Because the second statement also states that in any given pair, both politicians will not be honest at the same time. Why cannot they be honest at the same time? It must be because ekjoner beshi honest politician ekhane nai. That's why. All right? So go over the facts and think about why is it the scenario. Okay, these are the facts. So what must be the case for the crooked honest ratio that these facts are true? Still confused? If there are confusions, go ahead and ask. The entire purpose for these puzzles is to exert that sort of exercise in your brains, all right? So that you do these sorts of exercises, you think about these things when there are puzzles later on. So if you have any confusions, then we can always address that, even though the discussion has been quite long. But still, if there is any confusion, go ahead and state that. Anybody, is there anybody here who's who has any doubts regarding the solution itself, as in the answer, that the fact that there's going to be one honest politician and 99 crooked politicians? This answer, we're asked, right? The question, what is the question? The question is that how many politicians were honest and how many of them were crooked? That is the question. We're saying that only one is honest and all the other 99 are crooked. Regarding this answer, is there anybody here who has any doubts about it? Thinks that, okay, it's possible that this could not be the answer. Okay. All right then. In that case, if you are sure that that is going to be the answer, if you're sure that that is going to be the answer, in that case, this keeping the position of A fixed is just our way of establishing this fact, all right? So this is one way of proving this. The other way I've talked about it as already, that if two politicians are not allowed to be honest at the same time, why is it? It must be that there cannot be more than one politician. That is one approach, and this is just another approach. So for the last time, guys, any remaining questions regarding the puzzle? Any questions that remain regarding the puzzle? Okay, none. All right, in that case, you can go over it later on as well in your free time. Pick your own brains a little bit. If you still feel that at some point something doesn't make sense, you can always get back to me regarding that. Send me an email. We can schedule a consultation session or whatever, and then address those issues again. Okay. So if this is clear to everybody, then I take it that you are prepared for the quiz. Yes?
Anyway.
Not really.
Yes, please.